This is the tutorial of stoichiometric titration. The problem is, phosphoric acid is titrated with 0.1214 mole of sodium hydroxide standard solution. It takes 41.56 ml of sodium hydroxide to reach the endpoint. What is the mass of the phosphoric acid? First thing we need to do is make sure that our equation is balanced. And I note that its equation is balanced. Take note that we have a standard solution of 0.1214 moles of sodium hydroxide. So this is the standard solution that we are going to use to find out the mass of phosphoric acid. We know that during titration, it took 41.56 ml of sodium hydroxide to reach the end point. So what is the mass of the phosphoric acid? So, we need to know the molar ratio, and the molar ratio is 3 moles of sodium hydroxide per 1 mole of phosphoric acid. So, in this case, we need to make a plan. First step is to determine the mole of sodium hydroxide used, and then determine the moles of phosphoric acid. Well then, find the molar mass of the phosphoric acid, and with that, we'll calculate the mass of phosphoric acid. First is for moles calculation of sodium hydroxide. We have here 0.1214 moles of sodium hydroxide. And remember that the molarity means mole per liter of solution. All we have to do is to multiply that by 41.56 ml of sodium hydroxide. But we need to change the ml to liters. So, we're gonna move the decimal points to the left. So, it will become 0.4156 liters of sodium hydroxide. So, cancel out the liters. And the result is 5.045 times 10 to the power of negative 3 moles of sodium hydroxide. Now, let's do the calculations for the moles of phosphoric acid. We know that there are 5.04 times 10 to the power of negative 3 moles sodium hydroxide. We also know that there will be 1 mole of phosphoric acid and 3 mole of sodium hydroxide. We will use that to convert to get the moles of phosphoric acid. We will multiply the 5.045 times 10 to the power of negative 3 mole of sodium hydroxide into 1 mole of phosphoric acid and divided by 3 mole of sodium hydroxide. So let us cancel the mole of sodium hydroxide. So the result is 1.682 times 10 raised to the power of negative 3 mole of phosphoric acid. Next step is to get the molar mass. Let's get the molar mass of phosphoric acid. The molar mass of hydrogen is 1.01 gram per mole. And to find the molar mass of phosphoric acid, and that's about 30.97 grams per mole. And also the molar mass of oxygen, and that is 16.00 grams per mole. Now, let's calculate the molar mass of phosphoric acid. And the result is 98.00 gram of phosphoric acid. Now, what is the mass of phosphoric acid? Okay, now let's calculate the mass of phosphoric acid. We know that there will be 1.682 times 10 raised to the power of negative 3 and multiply that into 98 grams of phosphoric acid. 98 grams of phosphoric acid, which is 1 mole of phosphoric acid. And cancel out the mole of phosphoric acid, and we have the result of 1.648 grams of phosphoric acid.